All right, starting off with question 4, we're given two blocks of masses of 1,5 kg and 3,2 kgs, and they're connected by a light inextensible string. A 24 newtons force is applied on a system of blocks to move them up the incline, right? And they are moving up at a constant velocity. Now, what do we know so far if something is moving up at a constant velocity? Now, this simply means that your acceleration would be equals to 0, right? Now, what we know so far is that acceleration is equals to 0. Now shown is the diagram below, the 1,5 box experience a constant frictional force of 2 newtons, right, as it moves up the incline. So they gave us the kinetic frictional force, right? So this is the kinetic frictional force of the 1,5 kg block. Right. Now, what does the first question require from us? Now, the first question wants us to define Newton's second law. Now, the second question states that we must draw a label-free body diagram for all the forces acting on the 1,5 kg block. Now, remember the difference between your free body diagram and your force diagram. Now, with regards to your force diagram, right, your object is represented with a box. But as for your free body diagram, the object is represented with a solid dot, right? Now, let us try and identify all the forces present on the 1,5 kg block. Now, with regards to questions involving the free body diagram and the force diagram, your mark allocation indicates the number of forces that need to be present. Now, in this case, we have the mark allocation is 4, meaning that 4 forces needs to be present on the 1,5 kg block. So I'm going to start with my gravitational force. Now, because this is on a surface, it would also have a normal force. Because remember, normal force, it is that force that is exerted by a surface. Now, it's moving up the incline due to this string which is connected, and there would be tension on the string. So the second force is going to be, or the third force rather, it's going to be your tensional force. So far we have identified 3. The last one, because it's moving on a rough surface, and they also give us the kinetic frictional force, 2 newtons, right? And remember, your frictional force is always opposite to the motion or the direction of motion. Now, in this case, if this is moving up, your frictional force would be going downwards. Now, in this case, these are the 4 forces present, but then if you wanted to add the components of HG, right? If you wanted to add the components of FG, for instance, your FG perpendicular and FG parallel, feel free to add them. Now, in this case, we'll just add them, right? But then if you wanted to leave your answer in this form, still correct, you would still get the full marks, right? Now, if we were to add the gravity components, remember we have your FG perpendicular as well as your FG parallel. Now, your FG parallel is always going down the incline. Now, you look at your angle. Your reference angle is here, so it's always going towards it, right? Now, what do I mean by this? Let's say maybe our inclined plane was like this, right? Now, if our object is here, where would our FG parallel be directed? Now, remember, your FG parallel, it goes down your inclined plane. Now, meaning that your FG parallel would be in this direction. Now, 4.3.1 is calculate the tension in the string connecting the blocks. Now, this is the string, right, which is connecting the blocks. Let me highlight it here, right? Now, the tension on this string is going to be equal. What do I mean by that? The tension on the 1,5 kg block and also the tension on the 3,2 kgs block is going to be the same, or it's going to have the same magnitude. What is the difference between the two tensions? It is the directions. Basically, the two tensions would have equal magnitude, but different directions, right? And in this case, we're choosing upwards as positive. So our upwards direction is positive and downwards is negative. Now, meaning that one of our tension, now in this case, the 1,5 kg blocks, our tension is in this direction, the upward direction. So it's going to be positive. Now for the 3,2 kgs block, our tension is in this direction. So it's going to be negative. All right. Now, what information do we have? So we have more information on the 1,5 kg blocks, right? Meaning that we need to use this 1,5 kg block to calculate this tension here. Right. Now, first, I'm going to start by writing down my Newton's second law formula. Now, which states that my F net, it is equals to mass times acceleration. Now, let me explain the concept of F net very well. Now, F net is the sum of all your forces acting on the block. Now, you need to look at the direction in which your object is moving. Now, for instance, if your object is moving horizontally, right, to the left or right, your F net is going to be the sum of all your horizontal forces. Now, if your object is moving up and down, right, your F net is going to be the sum of all your vertical forces. Now, in this case, we will assume that, okay, let's say this one is moving horizontally, right? It's not up and down necessarily, even though it's an inclined plane. So F net is going to be the sum of all horizontal forces acting on the 1,5 kg block. Now let us identify those horizontal forces with their respective signs, because remember we said this side, if it's going that side, is negative. If it's going that side, is positive. Now, the first force, it is tension. What other force do I have? These ones, because they are going that direction, they're going to be negative. I have frictional force. I also have FG parallel. Right? These are the three horizontal forces that I have. Now, this is equals to mass times acceleration. Right? Now, I'm looking for T. So this is going to remain as the variable T. Am I given Fk? Yes. I'm given the kinetic frictional force in this case of the 1,5 kg blocks as 2 newtons, right? And I would say T minus 2 minus, now remember your Fg parallel, it is the same thing as your mg, right? Mass times gravitational acceleration, sine theta. Right. Now, let us try and substitute them. What is our mass? The mass is 1,5. Gravitational acceleration is always 9,8. Sine, now our angle of inclination is 20 degrees. Sine 20. And all this is equals to mass times acceleration. What is our mass? Our mass is 1,5. And what about acceleration? Because this is moving, or these blocks are moving on at a constant velocity, our acceleration for both these blocks is going to be equals to 0. Now also this multiplied by 0. Now obviously this right hand side is going to be equal to 0. Now if you say minus 2 minus 1,5 multiplied by 9,8 sine 20, punching it into your calculator, right, you should get negative 7,028 if I round off to two decimal places, right? So basically here we left with t minus 7,028, or you can say 0.3, and this is equals to 0. Now this simply means that your tension is equals to 7,03 newtons, and because tension is a force and a force is a vector quantity, it has both magnitude as well as direction, meaning that we need to allocate direction for this, and we said our upward movement is going to be positive, so we're going to say upwards. Right, now we have calculated our tension. Right, now let's look at the next question. Now the next question says we must calculate the coefficient of the kinetic frictional force between the 3,2 kg block and the surface. Now remember the formula for your kinetic frictional force. It is your mu k, which is the coefficient of your frictional force, multiplied by your normal force. Now in this case, they're requiring us to calculate this mu k, right? The coefficient of our kinetic frictional force. Now let us see, what do we first need to identify or rather calculate in order to go about finding our coefficient. Now we need to be able to determine the frictional force on the 3,2 kg blocks, because we are only given friction for the 1,5 kg. So this is the first thing we would need to calculate, our frictional force. Secondly, we need to determine or calculate the normal force on the 3,2 kg blocks. Now before we can go about doing all of that, first let us start by drawing a force diagram. Right, now drawing my force diagram, this is going to be my Fg, right, my gravitational force, and because this is on a surface, it would have normal force. Now, was there any force applied? Yes, there was a force applied of 24 newtons. So this is Fa for force applied. And there is tension, right? Remember, cos Y is connected with a string to the other block. There would be tension, T. And because it's moving on a rough surface, we would also have frictional force, Fk, which is what we're trying to determine in this case, or the first thing rather we're trying to determine. Right, now let us break down our gravitational force into its component, respectively your Fg perpendicular as well as your Fg parallel. So this is our Fg perpendicular, and this would be our Fg parallel. Now, let us start with determining the frictional force, and we would need to make use of this Newton's second law formula. Now remember, F net is the sum of all our horizontal forces. Now, what horizontal forces do we have? I'm going to first start off with the positive ones. We have force applied, we have frictional force, we have tension, we have Fg parallel, which also can be written as mg sine theta, and all this is equal to our mass multiplied by acceleration. Now let's substitute what we have. What is our force applied? Our force applied is 24. Frictional force is what we're looking for, so I'm going to say minus Fk. What about tension? We have calculated tension before as 7,03, right? Minus mg sine theta. What is our mass? Our mass in this case is 3,2. Gravitational acceleration is always 9,8 sine 20. And this is equals to our mass, which is 3,2, multiplied by our acceleration, which is 0. Remember, it's moving at a constant velocity. Now, in your calculator, if you see 24 minus 7,03 minus, and you say in brackets, 3,2 multiplied by 9,8 sine 20, right? Punching it into your calculator. Now you should get a value of, right? So remember, you still have minus fk here, plus, now you get 6,244, right? 6,244, and remember that other side is equals to 0, so that when you take your fk to the other side, basically your frictional force in this case will be equal to 6,244 newtons, right? But remember, we are not calculating for, or this is not our final answer. We are looking for this mu k. Now we've already calculated the frictional force. Let us try and calculate the normal force. Now let's look into this force diagram, right? Now, can you see that actually, now let me erase this fg, right? So if I erase this, because it's already in its components, we have fg perpendicular as well as fg parallel, right? So normally this should look like this. Now, can you see that when we're looking at the vertical forces, the only forces present, it's the normal force as well as your fg perpendicular. Now, if that's the case, this simply means that our normal force in this case would be equal to our fg perpendicular, right? Meaning that if we can be able to identify or rather calculate fg perpendicular, we would get also the value of our normal force. Now, let us try and calculate fg perpendicular. Now, remember, fg perpendicular is mg cos theta. Now, what is our mass? Our mass is 3,2. Gravitational acceleration 9,8 cos of 20. Right. Now, if you punch this to your calculator, you should get a value of 29,46876 newtons. Right. So here's 29. Right. This is your normal force. Now, let us go back to this formula that we wrote initially here. So our FK, we said is 6,244. And we said this is equals to mu k, which is what we're looking for, multiplied by our normal force, which is 29,46876. Right. Now, because we are looking for mu k, we're going to try and eliminate this 29,46876 by simply dividing both sides by 8. Right. Now, let us go about doing that. Now, if we do that, these two are going to cancel out with one another, and we're going to be left with the coefficient of friction this side. Now, our final answer, if you punch this into your calculator, you should get your mu k as 0,21. 0,21. And this would be your final answer. Now, on question 3, we're given two blocks of masses of 5 kg and 2 kg, which are connected by a light in extensible string. Now, force F is applied, and this force F is applied at an angle of 20 degrees, right, on the 5 kg blocks. Now, and the system of block accelerate to the right at 2 meters per second, so they give us acceleration, right? And now let us choose directions, right? Let us say to the right it's positive, right? To the right it's positive, and to the left it's negative. Same applies to your up and down. Up it's positive, down it's negative, right? Now, they say the kinetic frictional force on the 5 kg block, right, it's 10 newtons. So they gave us kinetic frictional force on the 5 kg blocks. Now, 3.1 says define a normal force. Now, remember, your normal force is that force that is exerted by a surface. And always that force would be perpendicular to the surface. Always know that your normal force is perpendicular to your surface, or it's acting at 90 degrees to your surface. Now, in this case, an example is this. This is your, because this is on a surface, you would have a normal force. And this normal force is perpendicular to your surface. Now they say draw a free body diagram of all the forces acting on the 5 kg block. Now remember the difference between your free body diagram and your force diagram. Now your free body diagram, let's try. So the first force, it is our gravitational force. And as I've said, because this is on a surface, there will be normal force. And what else? We have force applied at an angle of 20 degrees. So you could just write FA. What else do we have? We have a string, right? Meaning that we will have tension here. And remember, the micro location gives us clue of the number of forces that need to be present. Now, in this case, I have 1, 2, 3, 4. I'm left with one force. Now, that force, because this is moving, it's going to have kinetic frictional force of 10 newtons in this case, and it was given. So the last force I need to recognize, it is my frictional force. Now, 3.3.1 says calculate the tension on the string, right? Now, let us see which block can we, because remember, the tension on the 5 kg block as well as the tension on the 2 kg blocks, they have the same magnitude. It's just that they're acting in opposite directions. So, okay, I could use the 5 kg. The problem is that with the 5 kgs, remember, I'm not given the force applied, right? So I can't use the 5 kg. But with the 2 kgs, let us see the forces present here and see maybe we can be able to determine them. So I have gravitational force and I have tension because this is connected by a string. So the only forces which are present on the 2 kg blocks, it is Fg as well as tension, right? Now we are determining tension. We can calculate Fg, right? Now remember, we'll be making use of that formula of F net is equals to mass times acceleration. We are given acceleration of 2 meters per second. Remember that acceleration is for the 5 kg block as well as the 2 kg block, right? Now taking that into consideration, let us calculate tension. Now F net is going to be the sum of our vertical forces in this case. Now we said up is forces, so it's going to be T minus mg. This is equals to mass times acceleration. Now we're looking for T, we don't have T, minus, what is the mass? It's 2 kg. Gravitational acceleration always 9.8. And this is equals to mass times acceleration. So this is 2, the mass is 2, the acceleration is also 2. So this is going to be T minus, so if you punch it into your calculator, 9.8 multiplied by 2, you get 19.6. It's equals to 2 times 2, which is 4. Now taking that 19.6 to the other side to be positive so that we can be only left with T, our tension in this case to be equals to 23.6 newtons. And because here it's going up, I'll just say upwards, because we chose upwards as positive. Now the next question wants us to calculate F. And in this case, this is our force applied. Now, if I were to draw a right angle triangle here, right, let me just draw a line here. All right. Now, because this 20 degrees, it's adjacent, because remember, we're looking for this horizontal component, right? Because it's adjacent to this line, we're going to use cos, right? Meaning that the F, the horizontal component of our F applied or our force applied is going to be force applied cos theta. And in this case, it's going to be cos 20, right? Why? Because remember, I said your F net, because this is moving horizontal, it's going to be the sum of all horizontal forces. Now, can you see your tension is horizontal, your kinetic frictional force is horizontal, they're acting horizontal, but your force applied, it's applied at an angle. We are looking for this x component of our force applied, right? And because our 20 degrees is adjacent to it, we use cos in this case. Now, let us make use of this formula to calculate the F. In this case, this FA, right? Or let me just write it as F cos 20, our force applied. Now I said F net is the sum of all the horizontal forces, right? Now I have F cos 20. I also have tension, which is going to the left, so I'm going to say minus T because I choose my left as negative. I also have frictional force, and all this is equals to mass times acceleration. Now let me substitute what I have. So I'm looking for this F, I have cos 20. What about my tension? I've calculated it as 23.6, so I'm going to say minus 23.6 minus my FK, my kinetic frictional force. I was given it as 10 newtons. Also, this minus 10. And this is equals to mass times acceleration. The mass is 5 kgs. Acceleration is 2 meters per second, right? Now, as a result, I would have F cos 20. Now, minus 23.6 minus 10, punching it into your calculator, you get minus 33.6. And this is equals to 10, right? From there, you would take this minus 33.6 to the other side so that it becomes a positive. All right. And now this side, you would have 43.6. Now remember, we are solving for f, right? Not f cos 20. So we're gonna divide both sides by cos 20 to get rid of this cos 20 so that we can be left with f only. So that these two would cancel out one another and we would be left with f. And in this case, our f would be equals to 46.40. Point 3.3 says calculate the coefficient of the kinetic frictional force. Similar to this question we were doing here, 4.3.2. Now remember the formula for your kinetic frictional force is Fk is equals to mu k multiplied by your normal force, right? Right? Now, we have, taking a look at what we have, right? Now we need the coefficient of the kinetic frictional force on the 5 kg blocks. What do we have with regards to the 5 kg blocks? Making reference to this formula, do we have our kinetic frictional force? Yes, we are given the kinetic frictional force as 10 newtons, right? So we have 10 already, and this is equals to mu k multiplied by normal force. Now, do we have the normal force? Nope, we need to calculate the normal force. Now, let us look into the free body diagram of the 5 kg block. And specifically, let us look at our vertical forces, right? Now, because this force applied is applied at an angle of 20 degrees, it will have its x component as well as its y component. Now, its x component is f cos theta. Its y component, because it's opposite to this 20, we're going to make use of sine. Can you see that this 20 is opposite to this? So to calculate the vertical component of this, we're going to say f sine theta, right? Because why? Our angle is opposite to our line. In this case is f sine 20, right? Now, let me just make, let us clarify this. How many vertical forces do we have? We have the gravitational force, we have the normal force, we have the y component of our force applied. Now we need to formulate an equation based on this. Basically, your Fg, or your gravitational force, and remember we choose downwards as negative, upwards as positive, right? So your Fg, it's always going to be equals to the sum of your vertical forces. Now it's going to be equals to your normal force plus the y component of your force applied, which is going to be F sine 20. Right. Now, let us go about calculating this. Mg, right? Your Fg, remember it's Mg. What is the mass? It's 5 kgs. Gravitational acceleration is always 9.8. And this is equals to the normal force, which is what we're looking for, plus force applied. Remember, we calculated our F as 46.40. So this is going to be 46.40 multiplied by sine 20. Now, the reason why these are positive, because these are going upwards, both of them, the normal force and your Fy, right? And if you take this mg to the other side, it's going to be negative, right? Now, in this case, if you punch this into your calculator, 5 multiplied by 9.8, this is going to be 49, right? So this side is equals to 49. R49, now this is still n plus. Now, if you take 46.40 sine 20 multiplied by sine 20, right? So you should get 15.87. But remember, do not round off up until you get to your final answer. Right? You just leave it as it is in this case, 15. Now, to get the normal force, we're going to take this 15.87 to the other side. So our n is going to be 49 minus 15.87. In this case, our normal force would be equals to 33.13 newtons, right? So 33.13 newtons. This is our normal force. Now, going back to this formula, remember we said 10, right? Our Fk is equals to mu k multiplied by normal force. Now, what is our Fk in terms of values? It is 10 newtons, which is equals to, we are looking for mu k, or the coefficient of kinetic friction, and all this multiplied by the normal force of 33.13. Now, to get mu k, we're going to divide both sides by 33.13, right? Now, punching that into your calculator, your coefficient of kinetic friction would be equal to 0.30. Right. Now, this is all for these questions, Newton second law questions. If ever you have any questions, always feel free to reach out.